Hi students, welcome to my channel Easy Maths by Uncle. This is the first video on statistics. Students, in 6th class and 7th class, you are studying something about how to find average of some given numbers. Okay, mean of some numbers. And tally marks, frequency, pi diagrams, all these also comes under statistics. But for 8th class students, they are having the chapter name frequency distribution tables and graphs. Okay, that is also statistics. Chapter name is different, frequency distribution tables and graphs. And 9th class and 10th class students, they are having the chapter name statistics. Right, those are studying NCERT course, they are also having in 9th and 10th statistics. In this video, I am going to cover complete introduction of statistics. So students, all of you subscribe this channel. By that you will get notifications for upcoming videos. Okay, you can understand statistics clearly if you follow my videos regularly. Right? See, first introduction and also definition of statistics. What is statistics? The extraction of meaningful information from data. That is called statistics. The extraction of meaningful information from data. So here we are having one new word, data. If we are having data, we can extract some meaningful information from this data. In other way also we can explain statistics. Statistics is the branch of mathematics. It is also one of the branch of mathematics which deals with the collection, organization, presentation, analysis and interpretation of data. Okay, so statistics is the branch of mathematics that deals with collection, organization, presentation, analysis and interpretation of data. We will learn all these words in the video only. Okay, see data. First of all, here also we are using word data. What is the meaning of data? Facts or figures collected for any specific purpose. Okay, for any specific purpose, we are collecting some figures or facts. That is said to be data. This data is again two types: primary data, secondary data. We will discuss now what is primary data, what is secondary data. Students, listen first. Statistics means every 10 years government of India collecting the census of India. Okay. So total population of India they are collecting. How they are collecting this information means they are giving duty for teachers. Teachers they are going door to door. They are writing the information what the family head is giving them particulars. Okay. By applying this data, the government of India announcing how many urban people are there in India, how many rural people are there, how much employment percentage, unemployment percentage, how many people are paying income tax, how many two-wheeler vehicles are there, four-wheeler vehicles are there. Okay. So all these comes under statistics. Right? Students, now we will discuss what is primary data, what is secondary data. Okay. Primary data. The information was collected by the investigator with a definite objective, then the data obtained is called primary data. The information was collected by the investigator with a definite objective, then it is said to be primary data. See, height of all students in your class. Any investigator or any officer will come to your class and he is writing height of all students or weight of each student. So they are entering height of students, weight of students. That information is said to be primary data. Okay. Now what is secondary data? Information collected from a source which had already stored the information. The data obtained is called secondary data. So information collected from a source which had already stored the information. The data is obtained secondary data. Suppose we are having attendance register and every day they are writing number of students absentees and presents. Okay. Now number of absentees in each day in your class for last month. Already information is there in the attendance register. That is primary data. By using that primary data, now we are entering again some other information. So on first day how many students present, how many students absent on second day. Number of absentees, number of presents. So by using the primary data, we are collecting some other information that is said to be secondary data. Okay, clear? Now, raw data. See, here primary data, secondary data, two types. That is different. Another name is there. Grouped data, ungrouped data. Okay, grouped data, ungrouped data. Now we are discussing about ungrouped data, that is also called raw data. Okay, so what is raw data? Raw data means it is ungrouped data. Raw data is also called ungrouped data. So if there is no change in the data and it is in the same form as it is collected, then it is said to be raw data. So whatever the information we are collecting, as it is, we are entering that. That is raw data. Okay. See here, marks obtained by 10 students. 10 students written the maths exam, suppose. They got the marks like this: 34, 16, 28, 31, 42, 50, 46, 38, 49, 33. So as it is, we are entering that marks. This is said to be ungrouped data or also raw data. Now array. What is array? Suppose the raw data when put in ascending order or descending order. For our convenient purpose, we will write these marks in ascending order or descending order. That is said to be array. Okay. So array means when the ungrouped data or raw data is arranged in ascending order or descending order, that is said to be array. Suppose same marks I entered here in ascending order. See, same marks: 16, 28, 31, 33, 34, 38, 42, 46, 40 and 50. This ascending order. So we say this is array. Okay. Now range. This is very important bit in all classes. What is the range? The difference between the highest and the lowest number of the data. That is called range. So whatever the information you collected, that raw data, what is the highest value? What is the least value? The difference between the maximum value and minimum value, that is said to be range. Suppose in this data, what is the maximum value? Highest marks 50. And what is the lowest score? 16. So highest value minus lowest value, 50 minus 16, 34 we are getting. So what is range? Maximum value of the data minus minimum value of the data. Okay. Students, next video onwards I will solve exercise problems. You can understand statistics very clearly. Okay. But before that you have to know definitions of all terms. Now we will discuss frequency distribution. What is frequency distribution? When the number of items is large. Number of items is large. Then we can convert it into the tabular form, which is called frequency distribution table. So when the number of items is large, we are going to convert it into tabular form. See, for understanding purpose, suppose in your class 30 students are there and maths sir conducted one test, slip test for 10 marks. Okay, the marks are like this: 7, 5, 3, 9, 10, 8, 8, 9, 7, 6, 0, 5, 3, like that song. Okay, see, the information is a little bit large. Okay, now what we will do? We will write one frequency distribution table. That is ungrouped data. What we are telling? That is ungrouped data. That ungrouped data we are writing in frequency distribution table. Here, first number of marks obtained by students. Okay. Number of students. First 0 marks. Suppose 4 students. 1 mark 5 students. 2 marks 3 students. 4 marks 1 student. 5 marks 6 students. Like that we are writing. Okay. See here. Suppose 8 marks repeated 3 times. 3 students got 8 marks. 8, 8, 8. Okay. So we are writing in frequency distribution table 8, that is marks. Okay. 3, that is frequency. So what is frequency? So number of repeated times. How many times it is repeating? How many times it is occurring? That is called frequency. Okay. This frequency distribution table and graphs, that is the chapter of 8th class friends. Okay, I told you already. So we are going to solve problems on that. Now what is frequency here? Frequency is the number of times the item comes in the table. Okay. So suppose we are telling 4 marks, 5 students got that. So for their frequency side we will write 5 number. Okay. That frequency is 5. 5 times it is repeating. 4 is repeating, 5 times. Okay, it is clear. Frequency, how many times it is repeating, that is called frequency. Now what is this? A representation of the data with actual observations with the frequencies in a table is called ungrouped frequency distribution table. Just now I told you, out of 30 students, we are writing in a tabular form. 0 marks, 1 marks, 2 marks, 3 marks, up to 10 marks. Okay, this is ungrouped frequency distribution table. We are not grouping here. Okay, only 1 marks, how many students, 2 marks, how many students, only in tabular form we are writing. That is frequency distribution table for ungrouped data. Right? Now, presenting the data in the form of simplifies and enables us to observe certain important features at a glance. This is called grouped frequency distribution table. Grouped frequency distribution table. Suppose 100 students are there. 100 students. Otherwise, only 30 students are there. Examination conducted for 100 marks. Okay? You think like this. 30 students, exam conducted for 100 marks. Now, marks like this. 47, 53, 92, 86, 17, 35, 49, like that. Okay? Then what we'll do? We will write here class interval. 0 to 10, how many students? 10 to 20, how many students? 20 to 30, how many students? Like this. Okay? So here we are writing class interval. 0 to 10, 10 to 20, 20 to 30. So this is called grouped frequency distribution table. Okay? So out of 30 students, how many students come into group 0 to 10? Either 4 students or 5 students, 3 students. Next 10 to 20, how many students are there in that group? Okay? We will do some problems on that also later. Okay? Now, the starting and end values of each class are called lower limit and upper limit of the class respectively. So starting, this is called lower limit. Ending, this is called upper limit. So these are lower limits, these are upper limits. Okay? So in every class interval, lower limit is there, upper limit is there. Right? In each class interval, the greatest number is the upper class limit. So in this class interval, 10 is greatest number, 10 is upper class limit. In this 10 to 20, 20 is greatest number, 20 is upper class limit. Similarly, in each class interval, the smallest number is the lower class interval. So 0 to 10, this is smallest number, lower class limit. 10 to 20, 10 is the smallest number, 10 is the lower class limit. Like that. Okay. Now, the difference between the upper limit and lower limit of every class interval, that is said to be class interval or class width or class size. See, this is one class, 0 to 10 class. Here 10 minus 0, we are getting 10. 10 to 20, upper class limit minus lower class limit. 20 minus 10, we are getting 10. The 10 is said to be class interval, class width or class size. Okay, so the difference between the upper limit and lower limit of every class is said to be class interval, class width, class size. Like that we can say. Now students, group data frequency distribution is 2 types. Group data frequency distribution. What are those 2 types? Inclusive and exclusive. Inclusive frequency distribution, it is also said to be discontinuous frequency distribution. Exclusive, it is also said to be continuous frequency distribution. See, what is the definition? If the upper limit of one class is different from the lower limit of the next class, then it is said to be inclusive or discontinuous class interval. Just by reading the definition we can't understand. With example you can follow this. I will give example. See, suppose class interval is like this. 1 to 10, 11 to 20, 21 to 30. Like that frequency, number of students got marks 1 to 10. Suppose 4 students, 11 to 20, 6 students, 21 to 30, 5 students, like that frequency is there. See here, what is the class interval? 1 to 10, 11 to 20. Here the upper limit of one class is difference of lower limit of the next class. Here 10 is there, here 11 is there. This is said to be inclusive class interval or discontinuous class interval. Why it is inclusive means the students who got marks 11 and 20 both are included here in this list. 11 marks here only, 20 marks here only. Now see, 20 21 to 30. Here, suppose students who got 21 marks also in this class interval, 30 marks also included here. That's why it is said to be inclusive type class interval. Okay, or discontinuous. Why it is discontinuous? See here. Here, suppose this is mark 1 to 10. Okay. Now again from 11 to 20. Once again 21 to 30. If you observe here, 1 to 10, 11 to 20, 21 to 30. Here some gap is there, 10 to 11 gap. Okay. What about this gap? Okay. So some difference is there. That is said to be class interval. Here it is discrete or discontinuous class interval. Okay. Now what about this continuous class interval? If the upper limit of one class is same as the lower limit of the next class, then it is said to be exclusive class interval type or also continuous class interval. This is like this: 0 to 10, 10 to 20, 20 to 30, like this class interval. Here frequency you can take 3, 8, 7, like that, any frequency. Here you observe upper limit of the one class is same as the lower limit of the next class. Here 20 is there, 20, 30 is there, 30 will come here. Okay, so this is said to be continuous class interval. If you line like this, see 0, 0 to 10, once again from 10 to 20, once again from 10 to 30, 0 to 10, 10 to 20, 20 to 30. This is continuous type class interval. Okay, suppose here when we will use continuous class interval, when we will use discontinuous class interval, you have to understand. For that, say measures of central tendency. We are having in this statistics measure of central tendency. This is important. Measure of central tendency. Here you have to remember three items. One is mean, next is median, another one is mode. So three values are there: mean, median, mode. These three are said to be measure of central tendency. Okay. Here in this chapter we will discuss very clearly mean, median, mode with formulas. Okay. But whenever we are calculating mean in grouped frequency distribution, directly we can do in any time. Okay. But particularly for median and mode, in that formula we are using lower limits. Okay. That time definitely we have to convert class interval of this discontinuous class interval or inclusive class interval. Must and should you have to change into exclusive class interval. So how to convert that? Just observe here. 1 to 10, 11 to 20, 21 to 30. Here I told you gap, one number is there. Okay, one number gap. Just we make it off, means 0.5. You have to do one thing. Here right side you have to do plus 0.5. You add 0.5 to upper limits. Similarly, you reduce 0.5 from lower limits. Okay, what will happen that time? Just you observe here. 1 minus 0.5, you will get 0.5. Now 10 plus 0.5, you will get 10.5. Once again, 11 minus 0.5, you will get 10.5. 20 plus 0.5, it is 20.5. Once again here 21 minus 0.5, that is 20.5. 30 plus 0.5, 30.5. Observe your class interval. 0.5 to 10.5, 10.5 to 20.5, 20.5 to 30.5. Again, you are getting here continuous class interval. So, whenever there will be the problem in this pattern, you have to convert like this, means continuous class interval. Then only you can find median and mode. But for mean, you can do in any way. Okay? Right. Now, students, graphical representation of data. So, how to represent bar graph, histogram, frequency polygon. In 10th class you are having frequency curves also, 9th class also. Frequency polygon, next frequency curve. Polygon means by using scale we will draw. Frequency curve means with the free hand you have to join the points. Okay, that is different. Later we will discuss. Bar graph. So bar graph, it displays information using vertical or horizontal bars of uniform width and different lengths being proportional to the respective values is called bar graph. Means, suppose achievement in exam, we kept an examination for your class. Some students get A grade and some B grade, some C grade. Here, suppose 30 students get A grade. So how to represent this? In this graph, first leave 1 centimeter gap. Next, I am taking these 2 centimeters for A grade purpose. 30 students. So I am taking this side. Okay. This one. That is A grade. Okay. Now suppose B grade, 55 students. This is 30. I am writing here 30. Okay. Now 55. Again leave 1 centimeter gap. Take 2 centimeters for B grade. Here 50, 60, middle point you have to take. Okay. Now this is B grade. Now again leave 1 centimeter gap. For C grade you take next 2 centimeters. Suppose here 40 students they get C grade. So 40 you have to draw up to here. Okay. So this is 40. Here it is 55. So if you want, you can draw like this design also. Okay, one shade here in this pattern. Here like this. See, all these are vertical bars. Now here some conditions are there. The thickness of each bar should be the same. See, here thickness of bar we are maintaining same. Next, space between bars also should be the same. Here we are maintaining 1 cm gap, 1 cm gap, 1 cm gap like that. If we maintain equal gap, then bars it looks very nice. Okay. Now height of the bar should be according to the number of that have to be represented. So numerical data. Suppose here number 30 students get A grade. Okay. So up here we have taken 3 centimeters. Now here 55 students B grade 5.5 cm. Okay. So 40 students get C grade. So 4 cm height. Okay. So like that, according to number, this bars height will be there. Okay. In proportionate. Right. So on x-axis we are taking grades. On y-axis we are taking number of students. And also this scale, according to graph, according to numbers, we have to take. Okay. So here place is not convenient. That's why I have taken y-axis 1 centimeter to 10 students, 10, 20, 30 like that. In your graph sheet, you can take this 5, 10, 15, 20 like that because you are having some convenient space in your graph sheet. And next, you have to write here scale also. Okay. So right side top, you have to write the scale. What the scale you have taken? Actually, x-axis. What you have taken x-axis? Grade. X-axis you have taken grade. Now on y-axis, what we have taken y-axis? 1 centimeter equal to 10 students. Like that we have taken. Okay. 1 centimeter equal to 10 students. If you have taken 5 students, you have to write 1 centimeter equal to 5 students. So in some terms, we can represent this horizontal way also. These bar graphs are vertical. Suppose for sometimes we can represent horizontal bars also. Okay. Alright. Now we will discuss about histogram also next. Graphical representation of data, bar graphs completed. Now second one, histogram. Histogram is also similar to bar graph, but the only difference there we are maintaining gap between bars. Here continuously we will draw the bars. That is the only difference. Okay. So it is like the bar graph. Histogram is also like the bar graph only, but it is used in case of a continuous class interval. So there discrete class interval, here continuous class interval. With example I will explain now. Class intervals are to be taken along x-axis, class intervals, continuous class interval. Okay. See here example problem 0 to 5, 5 to 10, 10 to 15, 15 to 20, 20 to 25. This is continuous class interval. So we are putting exam for 25 marks. Now 0 to 5 number of students 7 members. 20 to 25 number of students 6 members. Total out of 45 students we are having frequency like this. Okay. This is continuous. So 0 to 5, 5 is there. 5 to 10, 10 is there. Okay. Same number is repeating. This is continuous class interval. Class intervals are to be taken along x-axis. The height represents the frequency of the respective class intervals. Now bar, how much height we have to take it? Depending upon the frequency. Okay. See, on y-axis number of students I am taking here. So 1 centimeter equal to 2 students, 2 members. Okay. 2, 4, 6, 8, 10 like that. Next, 0 to 5 class interval, 7 members, students. So 0 to 5, 7, 6, 7, 8 middle point. So 7, up to 7 we have to take it. Okay. This part. Okay. Next, 5 to 10, 10 members. 5 to 10 marks, 10 members. 10 it is here. Okay. So you draw once again like this. How many students? 5 to 10, 10 members. So I am plotting like this. It is not necessary the design. Okay. Next, 10 to 15, 14 members. 10 to 15, 14 members. Here 14 is there. Okay. $14 members, 10 to 15. Now 15 to 28 members. 15 to 28 members. Like that. Now 20 to 25, 6 members only. So 6 members. 6 members. Okay. And here 8 members. Finish. Right? This is said to be histogram. Okay. Same birth of type. But here continuous class interval. 0 to 5, 5 to 10, 10 to 15. There is no gap between bars. Okay. All bars are rectangles. Right? Width should be equal here also. Height is changing depending upon the frequency. Okay. According to scale, we can plot the graph. And one more thing, you have to mention scale here. Okay. Don't forget that scale. Along x-axis, marks. Okay. So 1 centimeter equal to 5 marks. 1 centimeter equal to 5 marks. Along y-axis, 1 centimeter equal to 2 students. Okay. This actually in textbook problem is there. There they have done some mistake. Small mistake. What is that? Number of students they have taken along x-axis. Marks they have taken along y-axis. Actually, we have to take marks on x-axis, number of students on y-axis. Okay, right. Now we will discuss third one. Okay, frequency polygon. Students, this is the last part. Frequency polygon. To draw the frequency polygon, first we need to draw histogram. So first we have to draw histogram. So last problem I am continuing. Same example. Okay. Already we plotted histogram. These are bars, continuous bars. So we are telling that is a histogram. Now what to do? Then join the midpoints of the top of the bars. So here bars are there. At the top we need midpoints. So 0 to 5 midpoint is 2.5. 5 to 10 midpoint is 7.5. Okay. Like that. We say it is midpoint of class interval or class mark also. So we have to find the midpoint at the top of the bar. This is the midpoint. And here it is another midpoint. Here next class interval. Here and here. Okay. Now we have to join all these points by using scale. Okay. See, like this. Yeah. So this is said to be frequency polygon. Okay. Now finally we will close this. 0 to 5 like that. Here also 1 centimeter back side we have to come. Okay. Here midpoint is this one. Join these two. Okay. Here also extra you take midpoint here. Join these two. Okay. You can name like this. Here first one A. Here it is B. This is C. Here D. Here E. F. Finally G. Like this closed polygon it is. Right? This is said to be frequency polygon. Okay, we will do some problems on that. Without drawing a histogram. Here we plotted the histogram and we are finding midpoints on the top of the bars. Joining the points we are getting frequency polygon. Suppose without this frequency histogram, how to draw this one? That time first we need here midpoints of these class intervals. We need to calculate the class mark of each class interval. So class mark means here I am writing mid values. Okay, mid values means here 2.5, now 7.5, 12.5, 17.5, 22.5. Okay, you add these two and by 2 mid value. 0 plus 5 by 2, 5 plus 10 by 2. Like that you can find mid values. For that corresponding frequency here 7. Okay, for 2.5 we have to plug 7. For 7.5 we have to take 10. Like that corresponding frequency we have to take. So for 2.5 it is 7. For 7.5 it is 10. Now 12.5 it is 40. Like that we have to plot the points on the graph directly and join the points by using a scale. You will get this polygon directly without drawing the histogram also. Okay. Actually, finally we are having frequency curve also. Frequency polygon, after that frequency curve, cumulative frequency curve. Okay. How to plot that frequency curves? With the free hand we have to join these points. That is said to be frequency curve. Simple thing. Okay. So today I am stopping this introduction. Now we will start problems from next videos onwards. Okay. Thank you for watching this video.